Okay, let's just take a look at some applications, several very good ones. Airplanes must be equipped with emergency locator transmitters that give a radio signal in the event of a crash. A value describing a characteristic of that transmittal signal is found from this expression. They just want us to combine these fractions. So essentially, we need to find a common denominator between all of these. And my guess is that 24 divides into 120 5 times probably. And we know 2 divides into 120. So let's let the least common denominator of these be 120. So can you see that a 1 would need to be written as 120 over 120? That is the number 1. But this 2 would need to be multiplied by a 60 for that to become a denominator of 120. So we'd have a 60x squared in the numerator over that 120. I mentioned a minute ago that 24 needs to be multiplied by 5 in order to get 120. So will this x to the 4th. So that will be 5x to the 4th over 120. And finally, the last term is subtract x to the 6th over 120. So now, because they all have common denominators, I can go ahead and put their numerators together. If I want to put it descending order of the exponent, I could put the x to the 6th term first with its minus sign, then the 5x to the 4th. Then the minus 60x to the 2nd, and finally the positive 120, with all of this being over 120. That's a little bit easier maybe to work with than the original expression. It's very true in this one. In a parallel circuit, the total resistance is described by, and this R right here stands for the total resistance. I will just kind of try to tell you that in a parallel circuit, this is a picture of that situation, that these two resistors are parallel to one another as opposed to in series. And so we might call this R sub 1 and R sub 2. And the total resistance coming across those two is defined by R sub t. But they just want us to combine the two fractions on the right side of this equation. And the least common denominator between those two fractions is R sub 1 and R sub 2. So the first one has to be multiplied by R sub 2, top and bottom. And the second one has to be multiplied by R sub 1, top and bottom. That makes the first fraction 1 times R sub 2 over R1, R2. And then the second fraction is 1 times R sub 1 over R1 times R2. And I'm ready now to add those. I'm going to go ahead and put the numerators in order. So I'm going to call it R sub 1 plus R sub 2 over the common denominator of R sub 1 times R sub 2. You know, if I wanted to take this statement and write an equation for the total resistance, I could just flip these because this is 1 over R sub t. So I could write this as R sub t over 1. And over here, I would have to then put the R1 and the R2 upstairs and the R1 plus R2 downstairs. We've done that already. We've found the total resistance of two resistors in parallel by taking their products and dividing it by their sums. All right. In determining the reliability of a medical screening test, a statistic's called the false positive rate is the quotient of this expression, and it's a complex rational expression. But a false positive, and I hope I'm correct on this, means that they tell you that you tested positively for cancer, and they were wrong. You really don't have it. A false positive. But what I want to do is simplify this expression. So I'm going to first work with this numerator first, and I'm going to notice that this has got a denominator of y. So I'm going to write this 1 right there as y over y, because that is 1. And then there's the fraction right behind it of 1 over y. And so the numerator is going to become y minus 1 over y. And I've taken care of this right here. You see this 1 right here? I'm going to make that ny over ny, because that is 1. This 1 right here is ny over ny. And now these two fractions have a common denominator. So this ny plus these two terms right here, so ny plus 10a minus n over the common denominator of ny is what's under this fraction. And actually, I should have put it right over here. ny plus 10a minus n over ny is the denominator of this complex rational expression. Well, I need to divide these. So when I divide, I have to take the first fraction and multiply by the flip of the second fraction. So I've got to take this y minus 1 over y and multiply it by the reciprocal of this one. So I'll put the ny upstairs and the ny plus the 10a minus the n downstairs. It happens in this one that all I can do is cross off the y here and the y here. That is n times y, so I'm able to remove those common factors. But in the end, this expression looks much better. It's this factor of n times this y minus 1. I don't need to do anything with it, over this right here. So I had to do some addition and subtraction first, and then I had to remove some common factors, so some multiplication. But this expression right here for a false positive is much better than working with this expression over here. Finally, I'm just going, these are almost ready. This would become a 9ny over an ny. So that you could combine these. Carefully, you got to subtract this sign right here. And I'm just going to tell you that a false negative says that you don't have cancer, but you really do. And when you simplify this false negative, I have 10 minus an over 9ny minus 10a plus 9n. See if you can get that. See if you can work this problem through to get this expression in the end. This concludes our study of adding and subtracting rational expressions. So we have been through simplifying algebraic fractions. We have multiplied and divided algebraic fractions, and we just finished adding and subtracting, which was the hardest, algebraic fractions. Our last unit is to solve rational equations, which are fractions in equations. It's quite a bit of fun, and it follows a lot of the procedure of adding and subtracting.